Hi grade 7! For today, I will discuss with you about the laws of exponents and the multiplication and division of polynomials. And it was based on Mathematics 7, Quarter 2, Module number 5.
This is from LRMDS Bulacan. Thank you and congratulations to the development team of this module. Credits to the author, language reviewer, content editor, illustrator, and layout artist of this module.
Hi learners! Are you ready? Let's learn! Have fun! Because mathematics is fun!
What I need to know.
This module provides varied activities that will help you to learn the laws of exponent and multiplication and division of polynomials. At the end of this module, you are expected to first, derive the laws of exponent. Number 2, multiply the polynomials such as monomial by monomial, monomial by polynomial with more than one term, binomial by binomial, polynomial with more than one term to polynomial with 3 or more terms. And lastly, number 3, divide polynomials such as polynomial by a monomial, polynomial by a polynomial with more than one term.
What I know. Turn your module to pages 3 and 4. Let's answer the pre-test. Read each item carefully and circle the letter of the correct answer. What's in? Arrange the following expressions in its standard form. Now let's try example number 1. 5y plus 3y cubed minus 5. What do you think is our first term? What do you think is the highest degree of the term? Correct, that is 3y cubed. Now what is our second term? Yes, 5y. In this case, we need to add plus sign in between terms. Our last term is negative 5. Now for our final answer, we have 3y cubed plus 5y minus 5. Example number 2. We have 8m squared minus 5m cubed plus 2m minus 11. Now what is the highest degree of the term? What is our first term? Okay, correct. Negative 5m cubed. For our second term, we have 8m squared. Again, we have to add plus sign in between terms. Our third term is positive 2m. And for our last term, we have negative 11, giving us the answer of negative 5m cubed plus 8m squared plus 2m minus 11. Example number 3. We have negative 6x cubed plus 6 minus x squared. What will be our first term? Correct, that is negative 6x cubed. What will be our second term? That is negative x squared. And for our third term, we have negative x. And for our final term, we have positive 6. We have our final answer as negative 6x cubed minus x squared minus x plus 6. Example number 4. We have x plus x cubed. What do you think is our first term? That is x cubed. And of course, our second term is positive x. We need to add the plus sign in between terms. Now we have x cubed plus x. Example number 5. We have 3a minus 7a squared. We always need to consider the exponent. We have negative 7a squared as our first term. And of course, we have 3a as our second term. Don't forget the sign in between terms. Our final answer is negative 7a squared plus 3a. Perform the indicated operations. Let's have example number 1. We have 3x plus 10x. Because they are similar terms, we can arrange it in vertical format. Now we can add the terms. Make sure to only add similar terms. First, bring down x. 3 plus 10 is 13. 13x is our answer. Example number 2. 5x minus 3x minus 8x plus 6x. They are all similar terms but different signs. To make it easier, combine the like sign first. First, let's add 5x and 6x. We have 11x. Proceed to negative 3x minus 8x. We have negative 11x. We can now simplify our answer. 11 minus 11 is equal to 0. Make sure that 0 has no sign and literal coefficient. Example number 3. 2x minus 3y. In this case, this is not similar term. We have x and we have y as our literal coefficient. All you have to do is to rewrite the terms. Our answer is 2x minus 3y. Example number 4. Negative 9x squared y plus 9x squared y. First, let's align it vertically. Now let's add. Because they are similar terms, we can bring down the literal coefficient. Now let's proceed to negative 9 plus 9. Because they have different signs, we will subtract the terms, giving us the answer of 0. Again, 0 has no sign and no literal coefficient. Example number 5. Negative 16 x to the 4th power plus 14 x to the 4th power. Again, let's align it vertically. Then proceed to addition. First, copy the literal coefficient. Negative 16 plus 14 is negative 2. Our final answer is negative 2 x to the 4th power. What's new? Give the product of each of the following expressions. Then write the exponential form of it. Now here is the table. We have the given, the product, and the exponential form. Let's have example number 1. 2 times 2 times 2 is equal to 8. In exponential form, we have 2 cubed. Example number 2. 5 times 5 times 5 is 125. In exponential form, we have 5 cubed. Example number 3. 3 times 3 is 9. In exponential form, we have 3 squared. Now we have 4 times 4 times 4 times 4 is equal to 256. In exponential form, we have 4 to the 4th power. Example number 5. 2 times 2 times 2 times 2 times 2 is 32. In exponential form, we have 2 to the 5th power. What is it? Lesson number 1. Laws of exponents.
I have here letter A and letter N. Letter A is the base and letter N is the exponent. The exponent N is also called power. Multiplying a number or variable N times means that the number or variable is raised to the N power. This can be read as A to the N power or A raised to the N power.
Now let's try example number 1. We have 7 times 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 7 is 7 to the 8th power or 7 raised to the 8th power. Example number 2. We have y times y times y times y times y is y to the 5th power or y raised to the 5th power. Example number 3. We have here AB times AB times AB times AB, giving us the answer of AB to the 4th power or AB raised to the 4th power. Now we have the product law. Study the table below. Compare the exponent of the factors to the exponent of the product. Now here is the table. We will give the expanded form and the product. We have 3 to the third power times 3 to the second power. We have here 3 and we have here another set of 3. The product is 3 to the fifth power. Example number 2. M to the third power and M to the fourth power. Now the product is M to the seventh power. Example number 3. 4 to the fifth power multiplied by 4 to the second power. This is 4 to the fifth and this is 4 squared. Our product is 4 to the seventh power. Lastly, we have x to the fourth power times x to the fifth power. Now giving us the product of x to the ninth power.
Multiplying powers with like bases. For any real numbers a and for any positive integers m and n, where a raised to the m power multiplied by a to the n power is also equal to a raised to the m power plus n. To multiply power with the same base, we have to copy the base and the second one add the exponents.
Example number 1. 2 to the fourth power multiplied by 2/3. We have 2 times 2 times 2 times 2 and 2 times 2 times 2. Or we have 2 to the fourth power plus 3. Now we have 2 to the seventh power, or in lowest term we have 128. Now we have example number 2. X squared times x cubed times x to the fifth power. X times x multiplied by x times x times x. Then we have x times x times x times x times x, or simply x to the second power plus 3 plus 5. That is x to the 10th power. Now we have x to the 10th power. Example number 3. 2x squared times 7x. In this case, you have to multiply it separately. We have 2 times 7 and x squared plus 1. For 2 times 7, we have 14. And x squared plus 1 is x cubed. That is 14x cubed. Now, study the table below and look for another pattern. Now, here is the table. In our given number 1, we have 4 squared raised to the third power. We have 3 sets of 4 squared, or 4 times 4 times 4 times 4 times 4 times 4, giving us the product of 4 to the 6th power. Next is m cubed to the 2nd power. We have 2 sets of m cubed, or we have 6 m's. That gives us the product of m to the 6th power. Lastly, we have 2 to the 3rd power raised to the 2nd power. We have 2 sets of 2 cubed, or 6 set of 2's. We have 2 to the 6th power.
Raise a power to a power. For any real number a and for any positive integers m and n, where a raised to the m power raised to the n power is also equivalent to a raised to the m power multiplied to the n power. To raise a power to another power, we have to first copy the base and the second one multiply the exponents.
Now let's have example number 1. 2 to the 2nd power raised to the 3rd power. First, let's use 3 sets of 2 squareds. That is also equal to 2 to the 2nd power times 3. That is 2 to the 6th power, or equivalent to 64. Example number 2. M to the 3rd power raised to the 2nd power multiplied by n to the 4th power raised to the 3rd power. First, we have 3m cubed. Then we have 3 sets of n to the 4th power. Now we have m cubed times 2 and n to the 4th power times 3. For m, we have m to the 6th power. And for n, we have n to the 12th power. Our final answer is m to the 6th power, n to the 12th power. Example number 3. 3 to the 4th power raised to the 2nd power. First, we have 3 to the 4th times 3 to the 4th, or 3 raised to the 4th power times 2. This will become 3 to the 8th power, or in simplest form, that is 6,561. Again, study the table below. Now here is the table. For number 1, we have 4x squared y raised to the 3rd power. In expanded form, we have 3 sets of 4x squared y. Or we have the set of 4, the set of x, and a set of y. Our product is 4 cubed x to the 6th power y cubed. For number 2, we have ab to the 3rd power. First, we have 3 sets of ab. Or we have 3a's and 3b. We have a cubed b cubed. The next one is c to the 4th power d cubed raised to the 2nd power. We have 2 sets of c to the 4th d cubed. Or we have 8c and 6d, giving us the product of c to the 8th power d to the 6th power.
Raising a power to a product. For any real number a and b, and for any positive integer n, where a and b is raised to the n power, is also equivalent to a raised to the n power multiplied by b raised to the n power. To find the power of a product, we have these 2 steps. The first one is to raise each factor to the given power, and the second one is to multiply the resulting powers.
Let's have example number 1. 3x squared y cubed raised to the 4th power. First, let's write 4 sets of 3x squared y cubed. Now let's combine the similar terms. First, let's have 3 to the 4th power. Then we have x squared times 4. And for y, we have y cubed times 4. To simplify, we have 3 to the 4th power, which is 81. For x, we have x to the 8th power. And for y, we have y to the 12th power. Our final answer is 81 x to the 8th power, y to the 12th power. Now we have example number 2. X cubed y raised to the 2nd power. First, let's have 2 sets of x cubed y. Our x is x cubed times 2. And for y, we have y1 times 2. Take note, if we have no exponent, that is equivalent to 1. For x, we have x to the 6th power. And for y, we have y to the 2nd power. Our final answer is x to the 6th power y squared. Now let's have example number 3. 4 times 5 raised to the 2nd power. First, we have 4 times 5 and 4 times 5. Or we have 4 squared and 5 squared. To simplify our answer, we have 60 and 25. Multiply these factors, we have 400.
Quotient law. For any non-zero real number a and for any integers m and n. Number 1. A raised to the m power over a to the n power is also equivalent to a raised to the m power minus n, if m is greater than n. Number 2. A to the m power over a to the n power is also equivalent to 1 over a to the n power minus m, if m is less than n. Number 3. A raised to the m power over a to the n power is also equivalent to a raised to 0 power, if m and n are equals. Take note, any number or any symbol raised to 0 is equal to 1.
Now look at the examples in the table below. Now here is the table. We have the exponential form, expanded form, and the quotient. X to the 5th power over x to the 3rd power. In expanded form, we have 5x in the numerator and 3x in the denominator. We can cancel out the value of x. X divided by x is equal to 1. We have remaining 2x in the numerator, and that is equivalent to x squared. Next example is 5 to the 6th power over 5 to the 9th power. In expanded form, we have 6 5 in the numerator and 9 5 in the denominator. 5 divided by 5 is 1. Just continue the process. Now we have 3 remaining 5s in the denominator. Now we have 1 over 5 cubed. Then we have a squared over a squared. We have 2a in the numerator and 2a in the denominator. We can cancel out a and a, giving us the value of 1. Now let's have example number 1. 15x to the 8th power over 3x to the 6th power. First we have 15 over 3. Then we have 8x in the numerator and 6x in the denominator. 15 divided by 3 is 5. Then let's simplify the numerical coefficient. X divided by x is 1. Just continue the process. Or simply x to the 8th power minus 6. Our final answer is 5x squared. Then we have example number 2. 24b to the 5th power over 4b to the 12th power. First we have 24 over 4. And for the literal coefficient, we have 5 b's in the numerator and 12 b's in the denominator. 24 divided by 4 is equal to 6. Then b divided by b is equal to 1. Or simply 1 over b to the 12th power minus 5. Our final answer is 6 over b to the 7th power. Example number 3. 35mn to the 20th power over 5mn to the 8th power. We have 35 over 5. Then we have m to the 1st power minus 1. And for letter n, we have n to the 20th power minus 8. Let's multiply 35 over 5. Yes, that is 7. For letter m, we have m to the 0 power. And for letter n, we have n to the 12th power. Our final answer is 7n to the 12th power. Just remember, if there is no exponent, that is equivalent to 1.
Remember for negative exponents, for any non-zero number a, where a raised to negative n is equivalent to 1 over a to the n power. We have no negative exponent. And for zero exponent, for any non-zero number a raised to 0 is equal to 1. Take note that any number or any symbol raised to 0 is equivalent to 1. Raising a quotient to a power. For any real numbers a and b, with b is not equal to 0, and for any integer n, a over b raised to the n power is also equivalent to a to the n power over b to the n power, or simply distribute the exponent to each term.
Now let's have example number 1. a over b raised to the 2nd power. First is to distribute the exponent. This will become a to the 2nd power over b to the 2nd power. And that will be our answer. Then we have example number 2. m squared over n cubed raised to 4. Distribute 4 to each term. M squared times 4. Also distribute the second one. We have n cubed to the 4th power. Now let's simplify. This will become m to the 8th power over n to the 12th power. Example number 3. Now we have 8x cubed over 4y to the 4th raised to the 2nd power. Again, let's distribute the exponent 2. This will become a to the 1st power times 2, x to the 3rd power times 2. Distribute again the exponent. The denominator will become 4 to the 1st power times 4 and y to the 4th power times 2. This will become 64 x to the 6th power over 16 y to the 8th power. Let's divide 64 by 16, giving us the answer of 4. X to the 6th over y to the 8th power. Our answer is 4x to the 6th power over y to the 8th power. Lesson number 2. Multiplication of polynomials. Multiplying polynomials requires knowledge of the law of exponents.
Monomial by monomial. Here are the steps in multiplying monomial by another monomial. Number 1. Simply multiply the numerical coefficient. And number 2. Multiply the literal coefficients by applying the basic laws of exponent.
Save example number 1. X cubed times x to the 5th power. In our given example, we have the same base, which is x. So all you have to do is to add its exponent, that is x to the 3rd power plus 5, giving us the answer of x to the 8th power. Example number 2. Negative 8 x squared y cubed multiplied by negative 9 x y to the 8th power. First, multiply the numerical coefficient. We have negative 8 multiplied by negative 9. Now multiply the literal coefficient. First is for x to the 2nd power plus 1. Then for y, we have y to the 3rd power plus 8. Now let's simplify. Negative 8 times negative 9 is 72. For x, we have x cubed. And for y, we have y to the 11th power, giving us the final answer of 72, x to the 8th power, y to the 11th power.
Monomial by polynomial with more than one term. Here are the steps in multiplying monomial by polynomial. Number 1. Apply the distributive property. And number 2. Follow the process of multiplying monomial by monomial.
Example number 1. 3y multiplied by y squared minus 4y plus 8. We will distribute 3y to each term of the polynomial. First, we have 3y multiplied by y squared. We have 3y cubed. Next is 3y multiplied by negative 4y. Our answer is negative 12y squared. Lastly, we have 3y multiplied by 8. Our answer is 24y. Then, simplify to get the final answer. Our final answer is 3x cubed minus 12y squared plus 24y. Now we have example number 2. 2a squared b multiplied by 6ab plus 8a squared b plus 9ab squared. Let's multiply the first term. 2a squared b multiplied by 6ab. We have 12a cubed b squared. Now let's multiply the second term. 2a squared b multiplied by 8a squared b, that is 16a to the 4th b squared. Let's proceed to the third term. 2a squared b multiplied by 9ab squared. We have 18a cubed b cubed. Then, simplify our answer. Our final answer is 12a cubed b squared plus 16a to the 4th b squared plus 18a cubed b cubed. Example number 3. Negative 4x squared y plus 12xy squared minus 20x squared y plus 5 multiplied by xy. In this example, we're going to use the vertical format, just like multiplying whole numbers. First, multiply 5 and xy. We have positive 5xy. Then multiply the second term, negative 20x squared y multiplied by xy. That is negative 20x cubed y squared. Now let's multiply the third term, 12xy squared times xy. And that is 12x squared y cubed. Lastly, multiply the fourth term. Multiply negative 4x squared y by xy. That is negative 4x cubed y squared. In this case, there is no similar terms. Our final answer is negative 4x cubed y squared plus 12x squared y cubed minus 20x cubed y squared plus 5xy.
Binomial by binomial. There are 3 steps on how to multiply binomial by binomial. Number 1, apply the distributive property. Number 2, the vertical form. And number 3, use the FOIL method.
Example for applying the distributive property. X plus 2 multiplied by x plus 3. Now we have x multiplied by x plus 2 plus 2 multiplied by x plus 3. First, let's distribute x. Multiply the two terms, we have x squared plus 2x. Then we have 2 multiplied by x plus 3. Our answer is 2x plus 6. As you can see, we have two similar terms, which is 2x. Just simplify. Our final answer is x squared plus 4x plus 6. Example for vertical form. 2a minus 3b multiplied by 5a plus 4. Now let's arrange in vertical form. Now let's multiply. 4 multiplied by negative 3b is negative 12b. 2a multiplied by 4 is 8a. Now let's proceed to the second term. 5a multiplied by negative 3b is negative 15ab. Take note, there is no similar terms, so I did not align negative 15ab. Next is 5a multiplied by 2a. We have 10a squared. Now, let's add the terms. For our final answer, we have 10a squared minus 15ab plus 8a minus 12b. Take note, the terms at the middle are not always the same. Remember that only similar terms can be combined. Example for FOIL method. 3a minus 2b multiplied by a plus b. Multiply the first term. Our first term here is 3a and a. Our answer is 3a squared. Now, the outer term. The outer term are 3a and b. Our answer is 3ab. Next one is the inner term. That is negative 2b times a. The answer is negative 2ab. Finally, we have our last term, negative 2b multiplied by b. The answer is negative b squared. Now we will add the terms. In our given, we can simplify the similar terms. So our final answer is 3a squared plus ab minus 2b squared. Lesson number 3. Division of polynomials. In dividing polynomials, you need to recall how to add, subtract, and multiply polynomials, and apply the laws of exponents for division.
Polynomials by a monomial. Steps in dividing polynomial by a monomial. Number 1. Simply divide each term of the polynomial by the given monomial. And number 2. Always simplify your answers.
Example number 1. 8m squared minus 6m divided by 2m. Let's divide the first term. We have 8m squared divided by 2m. Now let's divide the second term. We have negative 6m divided by 2m. Now let's simplify. 8 divided by 2 and m squared divided by m. That is 4m. Let's proceed to the second one. Negative 6 divided by 2 and m divided by 2. The answer is negative 3. So our final answer is 4m minus 3. Example number 2. 12x cubed y squared plus 21xy cubed minus 3xy divided by 3xy. Now let's divide the first term. 12x cubed y squared divided by 3xy. Let's divide the second term. 21xy cubed divided by 3xy. Now let's divide the third term. Negative 3xy divided by 3xy. Now let's simplify our answers. Let's divide the numerical coefficient. 12 divided by 3, x, and y. We have 4x squared y. For the second term, we have 21 divided by 3, divide x, and divide y. That is 7y squared. Lastly, let's divide the last term. Negative 3 divided by 3, x, and y. Dividing negative 3 and 3 will give us the quotient of negative 1. So our final answer is 4x squared y plus 7y squared minus 1.
Polynomials by a polynomial with more than one term. Simply follow the procedure in dividing numbers by long division of whole numbers. Here are the steps. Number 1. Check the dividend and the divisor if it is in standard form. If not, arrange it. Insert a 0 for any missing term. Number 2. Set up the long division. Number 3. Start the division, multiplication, subtraction, and bring down cycle. And number 4, stop the procedure when, first, the quotient has reached the constant term, and lastly, the exponent of the divisor is greater than the exponent of the dividend.
Let's try this example. Divide 6a squared plus 5a minus 6 by 3a minus 2. Here is our dividend. And here is our divisor. First, let's divide the first term of the dividend by the first term of the divisor. That is 2a. Next step is to multiply. Multiply 2a and 3a minus 2, giving us the product of 6a squared minus 4a. Next is to subtract. In subtracting polynomial, change the sign of the subtrahend, then proceed to addition. So we have to change the sign of 6a squared and 4a. 6a squared minus 6a squared is equal to 0. 5a plus 4a is 9a. Then, bring down negative 6. Let's proceed again in division. Divide the first term of the dividend by the first term of the divisor. That is equal to positive 3. For our next step is to multiply positive 3 by the divisor. 3 multiplied by 3 minus 2. Our answer is 9a minus 6. Then subtract. Then change the sign of the subtrahend, then proceed to addition. 9a minus 9a, 9a minus 6. Our answer has no remainder. Our final answer is 2a plus 3.
Are you ready to answer the module? Good luck!
What's more? Dependent activity number 1. Turn your module to page 14. Match each item in column A with its respective lowest exponent in column B. Write the letter on the blank before each number. Dependent assessment number 1. Turn your module to page 14. Simplify each expressions using the laws of exponent. Write your answers on the blank. Independent activity number 2. Turn your module to page 15. True or false? Write the word true if the product of the given polynomial is correct and false if it is wrong. Write your answer on the blank. Independent assessment number 2. Turn your module to page 15. Divide the following monomials. Write your answers in the box. Independent activity number 3. Turn your module to page 15. Multiply the following polynomials. Show your solutions. Independent assessment number 3. Turn your module to page 16. Divide the following polynomial expressions. Show your solutions. What I have learned. Turn your module to page 16. Fill in the blanks with the correct word or words or expression to complete the given sentence. Choose your answer from the box below. What I can do. Turn your module to page 17. How can a student finish answering all the activities in a matter of 5 days of time? To solve the dilemma, answer the following expressions below. Then write the letter of the problem above the box that corresponds to the correct answer. Assessment. Turn your module to pages 17 up to 19. Let's answer the post-tests. Choose the letter of the correct answer. Write your answer on the blank before each number. Additional activity. Turn your module to pages 19 and 20. Simplify each expressions in the box. Then color the corresponding answer on the star on the next page. References.
It's time for you to answer your module. I hope that you learn a lot. Thanks for watching. Bye!